All right, guys, settle down. So we're about to begin our next talk, and it's about a very simple topic, just multiplayer. I mean, we can just implement it in a day, right? Right, Paolo? Take the stage.
You. Can you hear me well?
All right. Can everyone hear him?
Blah, blah, blah. OK. Hello, everyone, and welcome to this talk about going multiplayer, the mistakes you must avoid at all costs. In this talk, I'll show you some common mistakes that you must absolutely avoid if you want to succeed in the world of multiplayer games. But first, let me introduce myself. I'm Paolo Abela. I'm the CEO and CTO of Fatus Games. I'm also a multiplayer consultant. I work independently on that side. And I also work at Unity as a senior software engineer for multiplayer. I have more than 11 years in game development, of which 9 I spent working on multiplayer games, which is the reason why I'm with you today, to share a bit of my experience. So, these are the 7 deadly sins of multiplayer. We're going to go through all of them, so bear with me until the end. And if you have any questions, please write them down, because we'll have some Q&A at the end, so you will have like 10 minutes to ask questions. So, let's start with the first one, choosing the wrong authority model. And what is an authority model? Why do we need one? What are we talking about? So, in multiplayer games, somebody needs to make decisions. Somebody needs to decide if I got hit by a projectile, if something can spawn, and in general, who sees what. Okay, what players see the other players, for example. The authority model defines all of this. And we can basically have 2 authority models here. We can have a server authoritative model and a client authoritative model. So what you can see on the left is that we have a centralized server, which you can think about like a very powerful machine that runs our simulation. And the clients, which are the player devices, connect to the server. So they can be mobile phones, computers, whatever else. So what happens in a server authoritative model? The server makes all the decisions, while the clients send the inputs. So we have a centralized institution, that is the server, that makes all these decision and processing. Okay, so it's more secure, for example. On the other hand, we have a client-hosted model, where one of the clients is also the server. And you can see here that this poses a problem, because if the server is the person that decides everything, it means that in a client-hosted model, there is one player that decides everything. And this means that players can cheat in that case. So when we are talking about client-hosted, the client that is also the server, it's a host. Okay. And it has an unfair advantage, because all the inputs that the client sends, that the host sends, are processed immediately, for example. So we need to be very careful when we are planning our game, when we choose the authority model, because it will influence what type of games we can make. And what happens if I pick the wrong one? Well, if you pick the wrong one, you will have cheating, you will have a terrible user experience, and more complicated development. Why cheating? Because, again, if you pick a client-hosted model, for example, one of the clients will be able to make all the decisions. They will be able to cheat. They will be able to give themselves invulnerability to make in-app purchases go automatically, to be accepted automatically, for example. Why the terrible user experience? Well, because some of these models increase the latency. So they increase the time that information takes to travel from the client to the server and back. So it introduces lag. Okay, you press one button, and the action happens sometime in the future instead of happening immediately. And more complicated development, because, for example, if you can make a game with a client-hosted model, but you decide to go with the server authoritative one, you are going to introduce a lot of complexity in your code base. So to make things easier to understand, I made a little table that you can see here. And you can also see that I added a new model in the middle, which is the distributed authority. You can think of that like as an intermediate between the server authoritative and client authoritative, where the clients share all the responsibility to process the simulation. So it's more decentralized than server authoritative. So what is server authoritative good for? For anything that is competitive. If you are making an esports game like a MOBA, you want to go server authoritative. Okay. When do we go client authoritative? Well, in pretty much any other case. Whenever we are making a casual game, client authority is fine, because we don't need to care a lot about cheating. And distributed is a very special case because it's good for when you have a lot of clients connected at the same time. So if you're making a social hub or a game like Minecraft, you can think about distributed authority. What is the problem here? The problem is that we need to choose the right one, also taking into account several other factors like pricing. A several authoritative model requires a dedicated server. And a dedicated server, well, you have to pay for that. So it costs more than that. But it's secure. So it's not an option to avoid several authoritative if you are making a competitive game or if you have in-app purchases. You really need that. In the other cases, well, the situation gets better from the point of pricing. Client-hosted is super cheap, but it's not good for the authority, again. And what about the experience? Well, with a several authoritative model, you have a centralized server. It's a powerful machine. It has a lot of bandwidth that can send and receive. So the connection is usually powerful. It's stable. Okay. With client-hosted, well, it depends on the player because one of the players is the server. So if that player has a bad internet connection, the other players will also suffer from that. So we need to be very careful about this. But once we pick the right authority, the next question we need to ask ourselves is, what's the best netcode framework that we need to pick for our game? So what's a netcode framework to begin with? A netcode framework is a library. It's a code library that you add to your project. And it allows you to build the multiplayer features of your game. So we need it mainly to synchronize information across devices, to send data between players, and to spawn objects. Okay. And when we talk about netcode frameworks, we are not talking about what we refer to as services. Services are anything that is outside the game, but is functional to the game, like authentication, so login services, matchmaking. All these kinds of things are not usually handled by the netcode framework. So we are focusing just about the game. And as I said, what is the best netcode framework? This is a question that some of you might be thinking right now. You want to make a multiplayer game, we need to pick the best framework. The thing is that, to answer this question, we need to first understand this. Nobody ever will tell you, I picked a random netcode framework and it just worked. And that's for a simple reason. Because the best netcode framework depends on the game that you are making. So there is no one-size-fits-all. Let me explain. The thing is that different types of games require different types of optimizations. Okay? And there is a limit to how many of these features can be generalized by a framework without making the development experience complicated, okay? Without adding too many options that you need to configure. And this is very important, picking the right netcode framework, because choosing the wrong one will limit what your game can do. Let's make an example. So this guy is Mario. Mario is a fictionary, imaginary studio lead at a studio that does not exist, okay? And Mario and this team, they released a couple of successful multiplayer games. So Mario has a team of 5 veterans. They are super good at making games. They are super successful. The problem is that they never made a multiplayer game before. They only made single-player games. And one day, Mario is on LinkedIn, he's scrolling, and there is a post about how another team used netcode for game objects, which is a netcode framework, to build a competitive card game. So he goes back to his team and says, OK, guys, we're going to make a 100 players battle royale game with vehicles in 6 months using netcode for game objects, because he read that it was competitive, right? And it was good for PvP. So he thinks that's the right option. But what happens is that there are 2 problems with this. The first one is the expectation. 6 months for a project like that is impossible, okay? But apart from this, the second problem is that netcode for game objects is not built for that type of game. It's the wrong netcode framework. So what happens 6 months later, assuming that they managed to do that in 6 months, is that they are experiencing some issues, okay? They are playtesting and they hear from players, why are these vehicles rubber banding? Why can't I hit what I'm shooting at? And this is because there is problems in using a netcode framework that is not built around a specific type of games. Netcode for game objects is very bad for fast-paced gameplay. So when a player shoots at another player, they are not really seeing, like they're shooting at something that is not really there because there is latency, because there's the internet messing things up, and netcode for game object is not good at handling this. So what's the outcome of Mario's bad choices? So imagine that he pays $50K to his developers every month that they spent 6 months of development. So this little mistake to produce this build that needs to be thrown out and redone costed him $300,000. That's a lot of money. Of course, this is an example, but I can tell you that I spoke to 3 different teams as a multiplayer consultant that made this exact problem. So this happens a lot. And how do we solve it? How do we find the right framework? Well, we need to ask ourselves some questions. Okay, how many players are going to be in the game? What is the pace of the game? Is it slow-paced? Is it fast-paced? Does it have physics? You know, we need to think about how many entities are we going to spawn into the game. Are they going to be there all at the same time? Because all these aspects impact on our choice. So it's very important that we make this evaluation first before developing the game. And to make things easier to understand, I want to bring you some examples here of 3 very different games. So we have PUBG as the first one. PUBG, for those who do not know that, it's a battle royale game. So you have 100 players in a single session fighting each other to death. It's fast-paced because it's a shooter game. Okay, so you have players moving around, jumping, shooting, dashing, using vehicles, and so on. It's physics-based. You can jump, you can drive, you can fall, there is gravity, and so on. And there is a lot of network identities apart from the players, like you can collect weapons, you can collect drops, and so on. So for that type of game, we need something that is able not only to handle a large number of players, but also to handle physics well in a fast-paced content. So in that case, something like Photon or Netcode for Entities will be a good choice. Then we have League of Legends. League of Legends, it's a MOBA game. It has 10 players fighting each other in a relatively small map. It's still fast-paced, because it's very quick gameplay, but it's not physics-based in the same way as PUBG. It still has some physics, but not as heavy, as important as PUBG. So it can be simulated most of the time. But it has a lot of entities as well. Like it has players, minions, drops, wards, whatever. Okay. So in this case, we need something similar to what we would use for PUBG, but on a smaller scale and without the physics aspect. And in this case, something like Fishnet, for example, could be a better option. And then there is Aryokan. Aryokan is a game I'm working on. It's a collectible card game where players can create their own cards. So it's a 1v1 PvP game. It's competitive. Okay, so it's only 2 players per session. But it doesn't have physics. It's not fast-paced because it's a card game, so you play it in turns. Okay, and there's basically only the players as network identities, plus all the, what I call the cards modifications, so all the buffs and debuffs that cards got during the gameplay. So you can imagine that this is very different from League of Legends and from PUBG. And in this case, something like Netcode for Game Objects will actually be a good option. So what happens if we pick the wrong one? Like if I picked the framework that is good for PUBG and I developed Aryokan with that, could I do it? Yes, I could do it, but it would be way more complicated, so I don't need to do that. Okay, it's still a best case option in the sense that I can still make my game, while if I do the opposite, like if I use Netcode for Game Objects for PUBG, we end up in Mario's situation where nothing pretty much works. So once we understand what framework we need to use and what authority model we need to pick, the next question is, when do we start? When do we start implementing multiplayer? And this is where many, many studios fail because they treat multiplayer as something that can be added later on. They say, I'll make the single player version first, and then I can add multiplayer later on as an add-on or in a future update. Okay. And you can be sure that every time you hear somebody saying this, 6 months later they're going to be crying because they won't be able to do that. Because unless your game has 0 multiplayer features in it, and it's completely single player with no online, you can't add multiplayer later on. Multiplayer is the foundation of your game. Like you need to change all the systems so that they can be multiplayer. And you must write your systems in a way that when you play on the internet, you acknowledge and you compensate for things going wrong, for latency, and for the states and the inputs that need to be synchronized and validated to avoid cheating. So let's make an example of this single player to multiplayer conversion. Let's say that we want to make a post-apocalyptic game, survival. Okay, so we have a few main features. We have missions to gather resources. We have the possibility to recruit survivors for our missions, and then we can build and customize our outpost. So the single player version of this is pretty easy to do. Like, you can imagine that your team develops that, and at some point, your tech lead comes in and says, hey, we need to make a multiplayer version of this. What happens? What changes? So the missions now need to be synchronized and centralized and manage it server authoritatively to avoid cheating, because otherwise somebody could simply say, I want to gather all the resources that are in this mission without doing anything. And they could do that. If there's no validation, they could do that, okay, like in a single-player game. What about the survivors? Survivors, instead of being non-playable characters, now are going to be other players. So you need to synchronize their movement, you need to synchronize their actions. Like if I shoot on my device, the player playing with me needs to see that I am shooting on his client as well, on his device. Because otherwise they will just see the zombies dropping down dead, and my character will be just like this, not doing anything. So, and this information needs to travel the internet reliably, and when it travels, it will arrive later than when I sent my input. So the simulation needs to catch up, needs to be resynchronized. And then for the build and customize your outpost, well, of course, if I'm playing a multiplayer game of this kind, I probably want to attack and help other outposts. So even that needs to be synchronized, managed, and built by multiple players. So what is the main difference? Well, the main difference is that we're making another game. It's not the same game as before. And in addition to all these changes to the features, we'll also need to add all these services for managing those features. I will need to add services to recognize the players. I need to add services to recognize the missions, to save all this information in the cloud, which is very different than when you are making a single-player game. When you're making a single-player game, all this information can be saved locally on your computer. And even if somebody cheats, who cares? But when there is other players in the middle, when there is emotions of other players at stake, it's very, very important that we handle things properly, because if I start cheating, other players will be angry. And an angry player will stop playing the game and will go playing my competitor's game. So this is something that we do not want to happen. So when do we implement multiplayer? If you know that your game is going to be multiplayer at some point, be it in the near future or later on, you need to start implementing multiplayer from day one. There is no excuse, unfortunately. So you need to design and implement all the features so that they work in a networked environment, again, when there is the internet, when there is latency, okay? Even if the game runs in single-player mode. So this is a trick that you can do. You can run your game in host mode. Remember the authority model. Like you have the server and the client in the same device, and you connect to yourself. So basically, it's as if we are running the game in single-player, but the architecture underlying is still multiplayer. So I implement my features in a multiplayer way, and then I start a server, and then I connect to myself. And this means that I'm basically playing single-player, but on a multiplayer architecture. So if I want to make my game single-player first, I can use this trick, and I can set the foundation correctly anyway. And this is also good because it's scalable to one or more players later on. I don't have to rewrite all my game if I decide to add more players later on. I just need to tweak stuff. And remember, adding multiplayer later on is a huge risk. You will need to rewrite most of the features of your game, especially the ones about players, movements, and actions. And one common objection that I get when I recommend using the host mode trick is, oh, but we don't want players to go PvP from day one because the player base will be small. And that's a misconception, because that doesn't mean, like having a networked architecture doesn't mean that you have to implement PvP from day one. Again, you can simply run your game in host mode to have the foundational architecture there. And this allows you not only to test the game as if it's single player with a multiplayer architecture, but also to inject some latency and to stress test your game, which is the very important part, because again, when you are on the internet, the situation is very different than when you are developing and testing on your computer. Your computer has no latency. When I press a button, it immediately gets to the server, it immediately gets processed. But when you're on the internet, it takes time for information to travel between one device and the other. Okay? And that time impacts how the game simulates and how fast the game simulates the input. Okay? So you can inject, if you're playing ghost mode, you can inject simulation. You can say, and you can see, does my movement work when I have alpha second of latency? Does it work when there is lag in the middle? Does the shooting work? And this makes the difference between a game that works at release and a game that doesn't work at release. Okay. So now that we know the authority model, the netcode framework and that we need to implement multiplayer from day one, the next question is, how do I properly synchronize data between the players? And this leads us to the next mistake that many do, synchronizing unneeded data. So what does proper data synchronization mean? It means that we only synchronize two things, state and events. While one common mistake that teams that are new to development do is that they try to synchronize everything. They try to synchronize the UI, they try to synchronize the visual effects, the textures, anything. Okay. And that initially works because they are testing on their local machine. So again, there is no latency. But when you go on the internet and latency appears, you start seeing some problems. So proper data synchronization means that we synchronize just state and events. State is the variables, pretty much. Events is what happens. I pressed a button, I shot, I picked up something. Okay. But why? Why do we synchronize only those two things? Why don't we synchronize only state and events? Well, because pretty much anything else can be deterministically recreated, resimulated, recognized locally with some basic information. I don't need to synchronize textures if I know the name of the textures. I don't need to synchronize visual effects if I know the ID of the visual effect that I want to play. And let's make an example. Let's say that Mario's team almost ran out of money with the previous mistake, and now they are trying to make a clone of chess. So let's see, like let's start with the wrong approach first, the beginner approach of making a chess simulation. So in the wrong approach, you will synchronize the two players. You will synchronize one piece for each player. You will have one networked object for each piece of each player. And then, of course, since we are making the wrong approach, we will try to synchronize everything else, also the UI, the board, and so on. And since we want to make a competitive game, well, we want everything to be server authoritative, because that's chess. It's competitive. So the server will tell the clients everything. They will tell the clients when to play sounds. They will tell the clients if a move was approved, when to play animation, everything. So what's the problem with this? The problem is that this doesn't work. This is very bad. Like when you play and you move something, you will see that the information arrives too late. By the time it takes to go to the server and come back, you will have to wait 200 milliseconds, 300 milliseconds. And that you will be able to notice that. Also, the sounds will arrive late. The animations will play late. The game will feel very laggy. And also, there's another problem. Like when we synchronize the UI, the problem is that we spawn the UI on the server. And the server usually doesn't have a screen. So what if my UI scales based on the screen size? What will be the size of my UI? We don't know. It's probably going to break. Okay. So we really don't want to use this approach. Let's see something that works. Let's see the standard approach. Okay. The standard approach would be to synchronize the two players. Would also be to synchronize one piece per player, but this time we synchronize some specific information. We synchronize just the position. We synchronize who owns that piece. And we synchronize if that piece is alive or dead. So with that information, we can reconstruct the UI. If I know the position, I know where I need to put the piece. If I know if it's alive or not, I know if I can put it or if I need to hide it. These kinds of information. And what about the UI then? Well, we'll use something that is called prediction and reconciliation. So instead of synchronizing the UI directly from the server, we'll only send the inputs. We'll say, OK, I want to move this piece from this square to this other square. And while I'm sending this information, I already do that. I predict the result of my move on the clients. And then the server will tell me, OK, that's a good thing that you can do. Or no, you can't do that. If the server tells me OK, then I don't have anything else to do. I already did that. Because I simulated, I predicted the result. And if the server gives me a different result than the one that I predicted, I reconcile. So I alter my local state to move that piece back or to move that piece in another, where the server tells me that it should be. So this allows us to have a more snappy gameplay that doesn't lag. And this approach, assuming that we are synchronizing everything all the time, will cost us like 3 kilobytes of data per second with a tick rate of 10. What is a tick rate? Tick rate is how many times per second we synchronize networked data around. And this is a very, very important number when it comes to multiplayer games. Okay? Think of it like the frame rate, but for networked data. Okay? So with this approach, we use 3 kilobytes, and we support 16 pieces per player with this amount of data. But there is even a better approach, and the better approach is the professional approach. So in the professional approach, we synchronize the two players, of course, so the objects representing the two players. But instead of synchronizing the pieces individually, we synchronize the entire board state, the state, not the UI. And this is very, very important because every square is basically 1 byte. And since 1 byte is made up of 8 bits, we can have up to 256 values per byte. Okay, follow me for a moment. So what if the value of the byte variable is 0? Well, if it's 0, it means that the square is empty. But when it's not 0, we can take half of the values that are remaining to identify a piece of the first player or of the second player. So if the byte is between 1 and 127, like in the case of the green squares, that means that it's a piece of the first player. And depending on the value, if it's 1, if it's 2, if it's 3, we can identify the piece itself. Okay, so 1 is the king, 2 is the queen, and so on. And the same goes on the other side, with the red squares for the other player. So why is this approach better? Because it uses way, way, way less bandwidth, as you can see. It's just like 5 times less, and gives us the chance to support up to 127 unique pieces per player. So we can even go above the usual pieces that you have in chess. You can invent new ones, and you will still have room, and it will not cost you anything to add them compared to the previous one. So this approach is better, uses 80% less bandwidth, allows us to have 8 times more content. So it's a great thing to tell to your designers and technical leads when you're making an analysis and design for this type of project. Because if we think right about our data, you can see that we can take a great advantage, we can add more content, and we can save money. Bandwidth is something you pay for. So the less bandwidth you use to synchronize your data, the better it is. And now that we know about synchronization of data, something that comes up to mind is cheating. Because whenever we synchronize something, we need to take care of cheating. But what's one mistake that people do is thinking about cheating too early. Okay, while you need to think about data synchronization at the beginning because it's part of the design process, cheat prevention at the wrong time can really slow you down and introduce some unnecessary challenges. First of all, why do people cheat in games? Mainly 3 reasons. Because they want money, because they want social status, or because they want to feel powerful. When I say money, it's because who makes the cheats, sell them for profit. And who buys the cheats, sometimes buys cheats that allow them to bypass in-app purchases. So they want to unlock stuff for free. Social status means that cheaters want to feel like recognized, like they want to get to higher ranks, for example, in competitive games like League of Legends, you can say. And feeling powerful is something that everybody wants to do. But in the case of cheating, I just want to bend the rules of the game. Or I want to just stomp and destroy everybody else playing with me. I want to feel powerful. So what is the right time to focus on cheat prevention? Most studios do that either too early or too late. Too early means at the yellow line, okay, right before production, when you start making the prototype of the game. And some other studios do it too late, when they launch the game and cheaters are already there. The thing is, nobody's going to care about your game for a very long time, basically until you launch, okay? Because again, cheaters want these 3 things. Nobody is going to sell cheats for a game that is not released yet. Nobody's going to buy it. Nobody's going to buy the cheats, pretty much. So money is not an option there. Social status means nothing if you get high rank in a game nobody knows. And feeling powerful, yes, okay, that's something that you can still feel. But if there are no other players that you can feel powerful against, the value is not going to be there. So when is the right time? The right time is between pre-launch and launch. If you implement anti-cheating measures, so start worrying about cheating there, you will have enough time to actually address the problems. You will have a solid enough structure because you're coming from years or months of development, okay? And your game is not going to be already popular, so there's not going to be that pressure, that external pressure of cheating trying to break it, cheaters trying to break it. So this is a good time, pre-launch. Okay, we know pretty much everything that we need to know about the game itself. Now let's think about the release. When we want to release our game and we need to scale it, we need to be very careful about our servers. And we need to be very careful, specific about the builds that we upload on our servers. So it's very easy to make a build of your game and upload it to a server as it is, but it's also very expensive in the long term. Let me explain why. Basically because servers don't do most of the things that clients do. There's nobody watching a screen or playing with a keyboard on the server, so they don't need to do inputs, they don't need to play visual effects, they don't need to play audio. There's half of the assets, like the majority of the assets that you have in your projects, they're going to be completely useless on a server. Okay. And what happens if you keep them? If you keep them, well, the server has to load them, it has to process them, you have to build them while you're making the server build. So you will have a lot of negative consequences, like you will have increased build times, you will have bigger builds. Bigger builds means also that you have to have higher storage capacity to host that build of your game, so you will pay more. Any of those things, like keeping these assets, will make you pay more in the best case. In the worst case, it will increase the load times of your server. So that's an impact, a bad impact on user experience. And in the worst ever cases, you're going to exceed the limits usages of RAM and CPU in your server, which means that your server will crash. And when your server will crash, your players will not be happy, they will be angry, and when a player is angry, what do? They stop playing your game and they go play your competitor's game. And again, this is something that we want to avoid. So how do we optimize our server builds? Pretty easy. If you're using Unity, you can use the dedicated server build target. It will automatically strip out all the textures, media, and will make your build way leaner, reducing its size. And if you're not using that, or even if you're using that, you will still need to be sure that you're not synchronizing unneeded data. So refer to the previous slides and previous concepts. In general, make sure that, for example, your visual effects are not spawned over the network. They are not part of networked objects. Instead, you can have a local database, like a list of visual effects in your project, and you can recognize them by an ID. So whenever I want to play a visual effect, I just tell the clients, okay, you need to play a visual effect with ID 75. And I go in the list, I check, okay, what's the 75? And I spawn them locally. Okay. So there's no visual effect synchronization, I just send an ID. All right, so we have a build for our servers, but we also need to be sure that we are running the servers properly. And this is another mistake that can cost you money. If you see, for example, that your CPU usage on the server is very high, like consistently above 90%, you are probably running your game, your server build, without a cap, without a frame rate cap. And that means that the server will try to process as many frames as possible during when the process is running. And this impacts both the tick rate, of course, and the CPU usage. But why the tick rate? Again, the tick rate is the number of times per second that we send our networked data around. And it takes CPU power to send data around. So if your CPU is busy processing the frames, it will not have enough time to process the ticks in time. So what happens is that your tick rate decreases. And when the tick rate decreases, also the speed of the synchronization, the network synchronization decreases. So your game will start synchronizing data slower and slower. You shoot at something, instead of immediately hitting, you will hit like half a second later. And that is terrible. Or you move, and instead of moving immediately, you will move 1 second later. That's terrible. Okay. So you really, really need to be careful about that. It's very important to limit the frame rate of your server. Now, what is the right frame rate for your server? Well, it depends on the game. Usually, it's between the 20 and 120 frames per second range. You need to test, and you need to think, to see what happens, basically. How do we limit that? Well, if you're using Unity, you can just copy this little script. You simply set the target frame rate at the beginning, like when the server starts, and you disable the vertical synchronization, the vsync, because we don't need that on a server. There's no monitor. Again, there's no rendering. Tip number 2, about saving money on the servers and running them properly. Choosing the right operating system. So it's very easy to make a Windows build of your server and to upload it, because we usually develop on Windows. But it's also very expensive, because Windows asks you to pay for the license. So every time your server is running, you need to give Microsoft money. Okay. On the other hand, there are Linux servers. Linux servers are faster, and they're free. So you should try to have a Linux build of your servers. That's the core concept. Okay. The thing is that it's not easy to convert from Windows to Linux. You need to be careful about a lot of things. So you should start this conversion very early on. And just to give you an idea, that's the cost of license on Windows on Multiplay, which is Unity's game server hosting service. So you pay around 40 cents of dollars per hour. Okay, so if you're running an entire server for all the year, all day, you pay $400 additionally. And that's just for the license. This does not include RAM and CPU and bandwidth, which are the important things. Okay. On the other hand, Linux is free. So the choice is pretty easy. Last tip about this is to run your game in headless mode. So again, we are on a dedicated server. Dedicated server doesn't have any rendering, doesn't have any input. So, and we don't really need those systems to be there, to be initialized. So we can say that we want to run our game in headless mode by using a few parameters, okay? Especially using batch mode no graphics, we tell the server to run without initializing the graphic devices, without initializing the input, without initializing audio. So this makes the build go faster, okay? It saves CPU, it saves RAM, saves everything. It's just the best option that you can use whenever you are doing, whenever you are running a dedicated server. The only case in which you cannot use this is if you need to do some server-side mesh processing for your game, for data that needs to be synchronized. Like if you have a word that is being altered by the players in real time during the simulation, you can't use this stuff. But in any other case, you need to use that. Okay. And we also need to use the log file parameter because these other two, for some reason, disable the logging. All right, so to wrap up, we need to pick the right authority model and the right netcode framework before we start developing. Okay. We need to start implementing multiplayer from day one if we know that our game is going to be multiplayer, because otherwise we'll have to rework half of the game later on. We need to synchronize just state and events and forget about everything else, because we can retrieve that information deterministically. Okay. Cheating is a problem only when you're close to release. Focus on that too early and you will waste time and complicate your development process. And then servers don't need textures and soundtracks, so be sure to optimize your builds and also be sure to run them properly on Linux machines if you want to save some money. All right, thank you so much for being with me. I hope you enjoyed the talk. Now we'll have questions. Raise your hand if you have any questions, so we can. Okay, there's one there. Okay, cool. Is the microphone on? No, it doesn't seem on.
Hello.
Okay.
What would you categorize MMO games as? Like server-based, or is it distribution type server as well?
Okay, so the question is, what is the category of MMO games? Like, you're asking me if they are using distribution authority or something else. Yeah. So MMO games, contrary to what many things, are mostly client authoritative. Oh. Because there are, yes. Because the thing is that when you have, for example, the 100 players, that part can be distributed. Okay, so distribution authority is a good architecture.
Like the social hubs and stuff like
that. Yes,
that.
because it's basically a social hub. While the gameplay part, like when you go into the dungeon, for example, if you play Final Fantasy XIV, that part is usually client authoritative. So one is the host, and the other ones are just playing.
Any good netcode frameworks for like MMO specific games?
Nice question. I'm not an expert of MMOs, so I don't want to say stupid things. But anything that supports distributed authority for that part should be good.
Thank you.
Right, guys. Someone else?
There was another there. Yeah.
Okay.
On the bottom. Yes.
Okay. I don't think anyone's going so.
Hey, awesome talk. Thank you so much. I had one question about the kind of network architecture, and so there are some trade-offs like for larger software systems with modularity, right? So if you can manage messaging within, say, an object class, it becomes a bit easier, right? So when you have network objects that maybe know how to handle their own update state. And obviously, like a game engine can be smart enough not to send unnecessary updates, right, if there's no state change. So just curious to hear your thoughts on those trade-offs between like a really compact messaging format versus sort of software architecture modularity?
Okay, so the question is about the trade-offs between having a very compact messaging system that maybe doesn't use any of those frameworks and using one of those frameworks which has its own level of abstraction. Is that pretty much the question? Okay. So a messaging system is also referred to as like low-level netcode. Okay. It's, of course, faster and more optimized. The problem with all low-level things is that they are more complicated to use. So you have less abstraction. So you have to do everything yourself. Even with those frameworks, by the way, you can have that. Like you can implement you can choose to use low-level serialization for your own classes. Like you define how to serialize over the network some specific objects. Okay. Because maybe you don't want to send the entire object, you just want to send like some data about that. So you can do that. You have that flexibility. For somebody that is starting, I usually recommend to start with something that is more high level, like using one of those frameworks, because it makes your life easier. And if the need ever comes of using the something more low level, you can always do that. Does that answer the question? Mostly. Okay. Next question. Please raise your hand. Yes.
Hi. So, is it worth implementing a custom relay server, or can we just rely on some service provider like EdgeGap for that?
So the question is it worth implementing our own solutions, or should we just use some providers that are there? Okay. What I usually recommend is do not, under any circumstances, like 99.9% of time, implement your own solution for multiplayer. Okay. So the good thing is that there is Epic Online Services, there is Unity Gaming Services, there is Google Play Services. There are hundreds of providers that you can use that will make your life infinitely easier when implementing services. Same goes for netcode frameworks. Okay. Most of the features that you need, like 99.9% of features that you need, are already covered by netcode frameworks in the world. So usually try to use something that is already there, that has a community that you can ask for help. Because if you implement your own solution, what is the problem? The problem is that you are the only one that knows that. Okay. And it's not battle tested. So you don't know if it will scale, and if something breaks, you have nobody to ask for help. So unless you have a very specific case, just use something that exists. Does that answer the question? Yes.
All right, guys, just one more question.
So I had a question about P2P servers. Like, hello?
Okay. Sorry.
So I had a question about P2P servers. Instead of having a separate server where you store player data, what about servers that just communicate with each other through players, like peer-to-peer kind of servers? Are they reliable, or are they just like very experimental to be implemented?
So peer-to-peer exists. It's pretty much the concept of distributed authority. Pure peer-to-peer is not something that you commonly find in games. Like there is always somebody that acts as the server. Okay. So that's the closest thing that you get is the client-hosted model, where you have only clients, but one is also the server. So that's the closest you can get to peer-to-peer. Pure peer-to-peer with no centralized authority ever is not a thing that you will usually see in multiplayer. If you want something that is closest to that, you can either use distributed authority, if you have a very big number of players, or client-hosted. Does that answer the question? Yes or no? Yes. Okay, cool.
Okay, thank you, Paolo. Anyone else who's got questions, please take them offline, as we are sort of running out of time for the next session. Thank you so much for enlightening us with multiplayer and everything that we can do wrong. So yeah.